Okay guys, this video will instruct you guys how to just conduct for the Arima model on RStudio. So basically this is just kind of like a further expression of the regular auto Arima function, and we learn how to just conduct for all the things step by step. So you guys can just like understand better about how the Arima model works. So this is the practice 8.7, the Arima in RStudio. Okay, and in this one I'm going to use the equip data for demo. Okay, and if you not really remember about that, you can use equip and question symbol. Okay, so this is a monthly manufacturer of the electrical equipment, including like computer, electronic, and the optical product from the January of 1996 into March of 2012, and that's monthly data. Okay, so maybe it's also had the problem about the kind of trend pattern and also for the seasonality pattern. I want to see it better, so I want to see the structures of the equip. It's over here. Here we go, and we have up to 195 observations in total. Wow, that's quite a lot with me. And I want to see it like head of the equip. Okay, 20. Okay, so this is all the information monthly, right? And now that should be the time for us to apply. Of course, like we can just calculate and try to just plot it. So I want to use the equip, and I want to apply for auto plot function. Okay, so this is how it looks like. It also have some kinds of trend, I guess, circular and seasonality. So it's better for me to apply the STL decomposition. Up until now, we had the STL. That's the very good, right? The seasonal trend with loose decomposition. That's a very good approach to just do for their time series decomposition. And we use STL decomposition and retrieve the seasonally adjusted data. So I want to use for equip data, and then I apply it for STL, the S-dark window. That should be periodic. Okay, and we want to apply it for the seasonal adjusted. So I just want to retrieve for the seasonal adjusted data. This has been released like this way. It has removed for the seasonality from the data, and of course I want to save it like the data set. So just like an object called adjust. Alright, electronic equip adjusted. This will be my data. Now I want to plot it and see the seasonally adjusted data as we already do. So I use the auto plot for one more time, but now this one will be the adjust. Right, and I plot for this X level, that should be year. The Y level, that should be nothing. That should be better. Okay, and you see over here now it's no longer have the problem about the seasonality, but however, anyway, we see like a bit jump in and drop in several of like the periods, like from in the late of the 2000 we had a kind of big jump. The same thing happened after the 2005, but however in 2008 and 9 especially in the global crisis in finance of the 2008 and 9. We had the big drop. That's kind of the stuff. So answer, we see the color a trend, right? So that's of course the data is non-stationary. Okay, this should be the point, and that should be the time for me to different the data and display them by the graph. Okay, so I use for the EE adjusted data, and I want to use a different function to just apply for that. Okay, if I just do it, this is the different. Okay, the different data, and because it no longer need for the kind of seasonal adjusted, the seasonal different, because we already had removed it out, so it's better now to just stop it here. Okay, and after when I already apply for that, okay, I will use the CCTS display to just display for the main be equal to nothing. Okay, so I want to see and look like up until this point the data looks stationary Arima. Okay, and however with the ACF and PACF, you see like with the PACF we have the 1, 2, 3. So 1 through 3 of them will be lot 1, lot 2, and lot 3. They have an impact into the current values. So the suggest for a model, okay, the model of the Arima auto-aggressive 3 order. So the data is stationary. So that's mean it's ready for the Arima model, right? And it suggests for the PAC app, suggest the Arima auto-aggressive 3 model. So that's be the time for me to just try for that. We try the Arima. Okay, of course 300. No, of course like 311. You know why? Because we need to check for the do they really need for another different or not. Like up until this part, right? They different already run for. So if we really check it, okay, and we check it for the number of the different that we need, this will return run 1. So that's the reason why we had to run it like 1 time of the different. And another one, if I go and check it with the number of the seasonal different, this will return for 0. So that's mean the reason why for the RE part, auto regression part, that should be 3, and integration, that's mean the different, that should be 1. Okay, I suggest that should be Arima 310. But however, I also suggest for another one, maybe like the Arima 20210. Okay, and another one Arima like 311. Okay, let's try it and to see like is there any color different. So EE adjusted. Okay, and I want to apply it for the Arima function. Remember about that, you have to capital for the Arima function like this way. If not, that should be run for another Arima, but it's not the same with what we're doing. 310. Okay, and I want to summarize them. Okay, check it, and this should be it. We will just try to just use for adjust this or correct this archive key information criteria like band marking criteria for select the model, and at the same time I run for that another one that should be to Arima 210. Okay, and another one I run it for the Arima 311. Okay, so you can see over here the first model they represent for the corrected archive key information criteria like 5.81. The second one, they are a little bit larger. That means this is not so good. And the last one, they are a little bit smaller, 995.7. So until this point, with me, this is the best model. Most correct, more accurate model. Okay, that's really the point. And I would say that I will select this one, and I want to save it. Save the model. So after when running for the model already, I will save them like fit model. Okay, that should be the point. Anyway, if you try and check to find out the optimal model by auto Arima function, you can see out some kinds of function. For example, EE adjusted function. So I use auto Arima. Okay, and I use for the summarize function. So it's go very quick, and it's suggest for the Arima 310. That should be the original function. That's our original model. That's we suggest. But if we change it a little bit, right? Remember about that. I can change it a little bit. So I make it harder and go into the further selection. So I can choose and use the step Y equal to far and approximation equal to 42. So they will run out and select for me for the best model for the Arima, which could be the best one, and we will see like what will be the result it will be. Okay, here we go, and it suggests that with the auto Arima function, that is suggest for function for the model of Arima 311, and that's very close to our fit model. Okay, see, so that's the reason why sometimes we can just do it manually, or sometimes we do it automatically. If you don't have the time, that's better for you to just use auto Arima function. And let's check the residue. Of course, yeah, we have the model over here. So let's check the residue of the model. Okay, so check residue and fit model. Let's see. First of all, we can see something. You can see over here, does look quite a white noise, right? And also when you see for the Legend box test, the p-value is very large, larger than 0.05. So that means the Legend box test have the p-values equal to 0.2409 is larger than 0.5, and the time series of the residue a white noise. Okay, you can see it's white noise not only just for the time series plot, but also for the ACF. That's totally belong into the dash lines. So they be low for the threshold. So that means they are totally white noise. Okay, and that means now everything will be ready for the forecasting, right? We just need for you for the fit model and apply for the forecasting function, and this will be the forecasting. All right, of course we can also plot it, the forecasting. So we already have this one, right? And I just want to plot it. Auto plot. Here we go. Has been come out and suggest for us for the forecasting based on the Arima 311 model of Residue. Okay guys, so next we will try to practice 8.9, the seasonal Arima model. Okay. And in case like for seasonal Arima model, we will use the arrow retail. Okay, use the arrow retail data for the mode. Okay, and we first of all just investigate what exactly they are. Okay, that should be the quarterly retail trade in the euro zone, and this quarterly retail data from 1996 into 2011. Well, this could be the time for us to just take a look a little bit more. So I want to see for the structures of the data. Okay, and let's have a 64 observation. I want to see some kinds of them first. Data observation, like about 10 first, and this will be some of the first 10 of the observation. Actually, you can do it and see it all. Arrow detail, and just not too much, just 64 observation. Alright, now let's go and conduct the analysis step by step. By the first step, step 1, let's check. Okay, let's plot the data. Of course, plot the data first. This will be more important. So we do it by using auto plot function and retail. I want to see for the X level. Of course, that should be year, and the Y level, that should be retail index. Hope that is work. Okay, and you can see it's over here. Do you think like we still need for the further transformation or not? In case like just the data visualization is very hard to just assess about that, and this would be the time for us to run for the step 2. That could be check if we need to transform the data and making any different. Alright, so I'm going to use the check for the box lambda. I want to spy out the lambda for the box transformation, and this would be 1.99, so I will use it and call it the lambda. Okay, and say it like this way. Then later I'm going to just plot for the data that had already been transformed by the box lambda. The number will be lambda equal to lambda. Okay, and I run it, and it looked pretty the same. So I'm going to the step 3, viewing the model. Okay, so to do that, step 3.1, the unit root text. So how are we going to do it? Number of, you remember, different required. Okay, arrow retail. Yeah, and it's 2 different times. Number of seasonal different arrow retail. You need 1. Okay, so that should be the time for me to take the, this should be step 3.2, take the seasonal, very different same first. Okay, so with the arrow retail data, I'm going to just use this and different it. Okay, with the large equal to 4, that's a seasonally different. Okay, because that's just quarterly data. So I do it, and let's check it. Check the residue on no GGTS displays. And we can see it's over here. Alright. The GGTS has sold out that the model, they still have the problem. They still have their ACF and also the PACF suggest for the autocorrelation, and also for the suggestion about the chain of the data. It's happy not really so white noise and stationary. Okay, so this will be the time for us to go for the next step. Step 3.3. It looks like we still need to need the first difference and check the ACF and the PACF one more time. So one more time with this one, I not feel okay with about that. I want to say them, but with this in the middle, I wanted to insert for another different function. You see it? Okay. And now it should be the time for us to see how it looks like. The fluctuation of the time series now it look more stationary, but however there's still some kinds of structure that we still need to do it, and but however we still have the very large correlation between the large values. And now we go in and check it if we need. I'm going to check it, and if we need, like I will call it step 3.4, check if any further difference is required. Okay, because we not sure about that, so we're gonna check it if we need some kinds of number of the different still required, and 0. This means here no more further difference needed. That looks so good. Okay, we go into the step 4 of the analysis. So we check the residue of the model. So with this one more time, I'm going to check for the residue. Sorry. And you can see it over here. Alright. I already checked for the residue of the model, and I'm sorry. Yeah. Until this part, I already checked for the residue of the model, and it's look quite good. This is the same with what I already done before with the time series display. And it should be the time for me in the step 5 to develop the model. Here I will apply for the Arima 00013, and for the seasonal part that should be 011. Okay, and for the detail of why I developed this one, just please take a look into the textbook. The Arima model function apply for the row retail and the order. Very careful. C 0, 1, and 3, and I clarify about the seasonality. Seasonal equal to C 0, 1, 1. Okay. Yeah, it looks like there's a problem. Is this good? Okay. Yeah. It's good now, and I want to summarize this. The model fit 3 to see how it detail. This will be 1013 and 011. This will be the model, and the AICC will be like 68.39, and that's That's my model. Let's check the residue of the model. Okay, and you check residue with 3 model. White noise, look good. And the next step, step 7, let's forecast. As the model has been already ready, okay, so I just need to forecast for the model, and I use the forecast function with the x equal to 12 periods ahead, and I want to see it to the auto plot to see like how it looks like. This would be how it looks like. Okay. Anyway, like with you guys, and you don't want to waste the time for just develop for the model by yourself, you can use the auto Arima function, of course. So to do that, I will call this one will be fit for model, and I use auto Arima. Arima function. This should be the function of the auto Arima. I use for the same time series, and put in like the step y that's equal to 4, approximation equal to 4. That would take the time, but we can wait. And here we go. We can go and check it, like if that's really work. So I say the fit for function. So in case like that's really a kind of like a partly data that will automatically just assign for a seasonal Arima model, and over here that's suggest for like this will be 0, 1, 3 Arima with the seasonal part 0, 1, 1. Okay, that could be very close to what we already meant before. So the suggestion about the two models is the same, right? So that's the reason why our model now it works very well. And of course we can plus the forecasting with the fit for model. We apply it for the forecasting function, which is equal to 12 years ahead, and with this, okay, use the auto plot to see this, and it's the same. Okay, so I already demonstrated for you guys about how to run also for the manual, and so the auto Arima function to develop for the seasonal Arima function in this section. Thank you so much for your attention.